These are your 5-4 notes on solving compound inequalities. Today's lesson is going to involve solving 2 inequalities at the same time and looking for a solution set that encompasses both inequalities. So we're going to solve inequalities that are combined with an and then we're going to solve inequalities that have an or between them. It really makes a difference in how you solve and what your answers look like. Just like in the English language, if I say and or, it makes a big difference. So if I ask for a Xbox One for Christmas or an iPhone 10, it makes a big difference if I say or whether I ask for an Xbox One for Christmas and an iPhone 10. So the interpretation is slightly different. So the same thing applies in math. Compound inequality is an inequality involving more than one inequality. That's why it's compound. You solve each inequality separately, and then the solution of the compound inequality is either the intersection of the two, where the two cross, two solution sets cross, or the union, and that means everything. So the first compound we're going to talk about is the and compound inequalities. Both inequalities must be true. And the solution is the intersection of the solutions to each inequality, the overlap of the solutions to each inequality. So when I talk about the Christmas reference there and I talk about the Xbox One and the iPhone 10, if you only get one or the other, you're not satisfied if you said and. In order for that statement to work is for you to get both presents. So if you said and, you're not happy or satisfied until you get both. So it has to be true for both. If you look at this example here, just really quick, and compounds can be written a little bit different than using the word and. So if you see and over here, this one doesn't show the and, it shows the variable in between. Because when you have answers to and compound inequalities, majority of the time, they are found between. Okay, so when I look at this, I'm looking at this as an inequality, the variable, and one inequality, all the way up to the other inequality, and then this portion is the second inequality. So they kind of overlap, and the overlap is the solutions. So if I were to graph those solutions on this ordered pair, on this number line, x greater than -3, I would first have to locate where -3 is and where +5 is on the number line. And x greater than -3 is an open circle at -3 and everything to the right. Those are the solutions to the first inequality there. The solutions to the second inequality would be closed at 5 and everything to the left. So that would be the second inequality. And so the solutions to this particular problem are just the overlap sections. So it's just that area there. Those are the solutions to the compound. The green arrow here means nothing to the compound. The green arrow just tells you where those are the solutions to the second inequality, but not the first. These red arrow here are all the solutions to the first inequality, but not the second. And right in between are all the solutions to both. And so this is how I'd write my solution in the solution set. You put x such that -3 less than x less than 5. You use 2 less than symbols. Both are pointing to the smaller number. You put x in the middle. You put the smaller number to the left of the larger number. It's a little tricky to get used to, but once you get going on it, it's not so bad. Or compound inequalities. Only one inequality has to be true. So if you ask for an Xbox One or the iPhone 10, you're satisfied if you get one or the other. If you happen to get both, great. So there can include the overlap, but it doesn't have to overlap. So the solution is the union of all the solutions to each. It's everything, or what I like to put is or everything. Just to help you remember that or is everything, or everything. So in this example, my first inequality, again, if I locate where -3 is on this number line and where +5 is located, x less than -3 is open at -3 and to the left. X greater than or equal to 5 would be closed at 5 and to the right. And so the solution is both of these answers. The only part that's not a solution is this ugly section in the middle. So my solution here, I'd actually have to talk about this. So x such that x is less than negative 3, or this, x is greater than or equal to 5. When you write an or solution in set builder notation, you actually have to write the word or in there because they're going in opposite directions most of the time. So let's go ahead and try these. Here are two and inequalities, and I actually want to change one of these symbols. So if you would on your paper, make that a greater than. I think that's going to help us out a little bit. Okay, so I'm going to solve this first inequality here. This one I'm just going to mark in red. So if I add 8 and I add 8 to both sides, p is greater than or equal to 12. I'm going to switch that around so I can look at the p and the 12 the right way. I'm going to keep my inequality pointing at the 12, so I have to flip it. So that's my first inequality. I added 8 to 4, and I got p is greater than 12. And then when I look at, did I do this wrong? Maybe I don't want to change that. Let's keep that the way it is. And so, yep, and so then now, I'm sorry, I'm going to do the green. Add 14, p is less than or equal to 16. And so I've got this other value, p is less than or equal to 16. So I'm going to be greater than 12 and less than or equal to 16. And so when I do this, I'm going to put 12 to the left of 16. I want to put both numbers on the number line. I don't really need 0 on there at all. So the p greater than or equal to 12 is closed at 12 and to the right. P less than or equal to 16 is closed and to the left. And so where these two solutions meet in the middle, in between 12 and 16, are my solutions. So I'm going to interpret the number line. The number line is used to help us find the answer. It's not the answer. You now have to give me the answer. So these are my solutions, x, such that x is between, so put x in the middle, 12 and 16, put the numbers that x is between, and then put your less than or equal to signs. They were both equal to, so make sure your lines are on them. And there you have it. That's the solution to an and. So I apologize, we were not supposed to flip that. So erase any marks that you made around that inequality. I thought I was helping ourselves. For this next one, a little tricky. So I'm going to put it in a box. I'm going to start at the 2. I need everything, the inequality, all the way up to the next inequality. So I'm going to put that in a square, and I'm just going to write that over here. And I'm actually going to put the g plus 4 out in front and the 2 on the right. And I'm going to make sure that my inequality is pointing to the 2 because I like my variable on the left-hand side. Subtract 4 from both sides. G is greater than or equal to negative 2. So that's my first portion. Those are the solutions to the first inequality. The second inequality, I'm going to put a box around the 7, the inequality, all the way up to that first inequality. So you can only have one inequality symbol in each of these. So that inequality is g plus 4 less than 7. When I subtract 4 from both sides, g is less than 3. And so when we graph these on a number line, I'm looking for the overlap. Negative 2 goes to the right of 3. I'm sorry, to the left of 3. Negative 2 goes first. Negative 2 closed at negative 2, greater than is to the right. G less than 3 is open at 3 and to the left. So even though the red line goes through 3, 3 does not work for the second green inequality, so we can't include it in our solution set. So we'll still say that the solutions are right here. These are my solutions. Now I got to summarize what those solutions are. My solutions are x such that, put x in the middle because they're between. The numbers are between are negative 2 and positive 3. Point to your smaller numbers. We're going to include negative 2, but we're not going to include positive 3. So we'll leave the positive 3 as a less than. There's two examples of and inequalities. For your or inequalities, I believe this is the one we need to switch, but I won't do any switching until I know. Okay, so for your or inequalities, 4a plus 7 greater than 31. This is my first inequality right here. So 4a plus 7 greater than 31, I'm going to subtract 7. For A greater than 24, divide by 4. It's a positive 4, so A is greater than 6. So that's my first inequality, and it's not necessary, but I'm just going to make you change this, okay? Because I want it to show you what it looks like. So I'm going to say A was less than 5. That's just a typo. So A less than 5, there's no work to be done there. That's my second inequality. So when I graph these on a number line, this is an OR statement. So I have 5 to the left of 6. When I graph my first inequality, A greater than 6, open at 6 and to the right. When I graph my second inequality, A less than 5, so open at 5 and to the left. And notice they go in opposite directions. They don't always have to go in opposite directions, but the majority of the time they do. And it's okay that they don't overlap because they don't have to. These are the solutions that satisfy the second inequality. These are the solutions that satisfy the first inequality. It's okay that they don't satisfy both because we're saying or. So when I write my solutions, I just have to name both of them. So x such that, I'm going to describe this arrowhead. X is less than 5, or describe this area here, x is greater than 6. So you have to write or in your set builder notation for the or solutions. When I look at this next problem, I'm going to subtract 6 over. R is less than negative 14. That's my first inequality. My second inequality, notice I keep color coordinating. You're more than welcome to. If you want to use highlighters to graph, you can use a pen and a pencil or colored pencils. R is greater than negative 7. So I have my two solutions. Since negative 14 is smaller than negative 7, I'm going to put that to the left of negative 7. When I graph R less than negative 14, there's an open circle at negative 14 and to the left. R greater than negative 7 is an open circle at negative 7 and to the right. There's no overlap, but that's okay. Or is everything, or everything, right? So x such that, I'm going to describe this arrowhead. X is less than negative 14, or I'm going to describe this arrowhead, x is greater than negative 7. If you described the green arrow before the red, that is okay. Kind of awkward, kind of read things from left to right, but that would be okay. All right, I think we got a word problem here. Talks about a ski resort, and at the ski resort you have two options. You can either stay in a hotel room or you can stay in cabins. They give you the price or the cost of a hotel room, and then they give you the cost of the cabins. So if you notice, the cost of the hotel room, here's the hotel rooms, cost at most $89 per night. And the cabins, which would be my other factor here, variable, it still costs, talking about cost, at least $109 per night. So we have an at most and an at least inequality in here. So what they're saying is not all cabins are priced the same and not all hotel rooms are priced the same. But the most you'll pay for a hotel room is $89, and the least amount you'll pay for the cabins is $109. So we need to write a compound talking about our cost and figure out the amount a guest would pay per night at the resort. So we're going to give a range of values. So we got to decide first, is this an and or an or? So we're talking about hotels and cabins. Are you going to stay in both? I don't think so. You're either going to stay in a hotel room or a cabin. So it's going to be a hotel or a cabin that you're staying in when you go visit. You're not going to stay in both. So when we look at this, my hotel cost at most means it won't go any higher than $89. So my cost will be less than or equal to $89 for my hotels. For my cost for the cabin, my cost will be at least $109, so it'll be greater than or equal to $109. And so when I graph this, got 89 here, 109 here, trying to figure out the cost. the cost of the hotel would be equal to 89 or less. So I might pay this if I stay at a hotel. If I stay at a cabin, equal to 109 or to the right. And so when I interpret that, since it is an or, when it says describe the amount they'll pay, and a guest would either pay, they will pay $89 or less, or more than $109. If you wanted to, you could also just keep it as cost, such that cost is going to be less than or equal to 89, or cost is going to be greater than or equal to 109. I wrote it in words just because it was a story problem. We can hold off on this one for the classroom. So our lesson summary, I'm going to give you a freebie, I believe. Maybe, maybe not. I don't know where they're at. Give me 1 second here. All right, so I was having some problems with my board. You get a freebie on the lesson summary. We'll go over that last word problem in class, and then I need you to solve the compound inequality, show your work, show your number line, and then interpret the number line. The number line is not your answer. That is part of your work. Good luck.